Hello and welcome. This is a quick introduction to what SQL Server looks like prior to my lesson on installation. I just want people to see what SQL Server, how it appears, how you can make a quick query, a quick join. This tutorial is for people who have already operated a relational database, either Microsoft Access or something like that, and want to learn how to make queries typed out long form in SQL, the language of relational databases. If you type the queries out long form, you can make them more complex and more precise more quickly, and you don't need to operate Microsoft Access through its traditional way, which can be a little burdensome. SQL is very elegant. So if you know anything at all about tables or joins, this will be very easy for you. SQL Server has a command line in its basic client, but we will use SQL Server Management Studio, which is an easier to operate interface, which combines the best of both worlds. First off, this is the most basic interface. You open the Object Explorer panel in SQL Server and select your database. We have a database called ART, and this is already pre-made, or I made this. You'll have to learn how to create your own tables. Also, the database comes with some pre-installed ones, but my technique is to show you how to create tables, because that's, I think, a very basic, great way to start. So we're selecting in the Object Explorer ART database, and although we use a lot of command line or text instructions, we also do use the mouse for some things which cannot be done through the command line, because we're using SQL Server Management Studio, which is a GUI interface that sits on top of SQL Server, allowing us to write SQL queries, but also take advantage of the graphic user interface. So you get the best of both worlds. You can run SQL Server without Management Studio, but I never have. So yes, to direct the database to direct SQL Server to use the database, the command is use ART. You type it in a new query window and hit the execute button. And so we're just selecting a table. This table has 3 paintings in it, and we want to see them all. So the most simple command is select asterisk from table name, in this case paintings, and it will bring up the 3 paintings that are in the table. Select asterisk will bring up the entire table, all the fields and all the columns. We have very small tables here just for ease of use. And so this is what the table looks like close up. You can see we've got 7 columns. Very basic, but of course SQL Server can go up to hundreds and hundreds of columns and thousands of rows. But you don't really want to do that. The idea is to cut down the number of columns to optimize the balance between the size of each table and the number of tables, grouping all the relevant information into one table per topic. So artists will have a table, paintings will have a table, museums will have a table, all the related stuff will sit in its own related table, and then you knit them together as needed. That makes it much more efficient to operate, and allows the tables to be much, much larger. Have many, many more records, be more powerful. So now we're going to write a query which selects an individual characteristic which returns only a single line. So in this case we're saying select the painting title, artist, and museum from the paintings table, where the artist, and we're specifying one name. So it will only bring up the paintings by the artist I specified. So that will limit the size of the return of the query, whereas the previous one returned everything. Little select asterisk returned all the rows. This just brings back the rows which are related to the artist Patoni. So here we have a query which derives information from two tables joined together into a third new table, which is returned just for the purposes of the query. We have two tables in this database, painting and artist, and we are returning a join between the two tables on its common condition, or its common characteristic, which is the name of the artist. Name of the artist is in both the painting field and the artist's field. So if you look at this language, it's a little long, a little complex here, but once you learn this, you can make very complex queries very easily. You can nest them with parentheses. You can chain different conditions. It's much easier to type it out than operate a mouse and pull all the join conditions out of a drop-down list. So into the new query field, we type this long, complex query, which is basically telling us to select painting's title and artist name from the paintings field, and the name of the curator from the painting from the artist field, artists table, and the join condition being the fact that artists are in both the painting and artists tables. Sounds a little complex, but it's pretty easy. You can see the result, which is a new table which has two columns from one field, two columns from one table, and a column from the other table. This is a little complex. Let's look at and here you see the relationship table between the relationship diagram between the two tables. You'll see artist name and artist in the two different tables contain the same information. There are no other common columns to share between the two tables. If there were columns more than one column to share between the two tables, you'd probably have a design error that you'd want to remedy, because you only want information of one kind to be in one table. You don't want information duplicated around the database, because then you might have errors and it might not be properly updated in the secondary spots where the information lives. That's not the case here. It's nice and discrete. Everything in each table is related most closely to itself, and not to other phenomena. So thank you. That was just a quick tour. I wanted to show you what SQL Server looks like. Generally in databases, the more tables you have, the more ways you can model data. You could go crazy and have too many tables, but you don't want too many different types of information in any single table, because then you'll get redundancy and tables will get unnecessarily large and duplicative. The more tables you have, the more ways you can model data, and the more precise the tables are arrayed, you get larger data sets, and you can get much more precise returns. So next up we'll do an installation. It's a little complex, the installation of SQL Server. Then we'll be able to create tables and write queries. So I hope you continue. Thank you.